Okay, so today's lesson is word problems. So basically applying yesterday's lesson with word problems today. So let's just practice defining a variable and then writing a rational expression. So one of the main formulas you're going to have to use is our rate or our speed is distance divided by time. Okay, rate is distance divided by time. This is in your actual notes book where we left off yesterday. Yeah, okay. So that's one of them. What if I wanted distance equals? What did I do to both sides to get distance by itself? Multiply both sides by p. So we get distance equals RT. You can. I will not encourage it, but you can. Okay? The triangle. It's bad. The book teaches it. The notes you'll get today. And the last one is time then. If we want a time by itself, we divide both sides by, on this equation, r, so we get distance over your rate. Okay? Most of the time, because we're dealing with rational expressions, we're dealing with those two formulas. So the time it takes to travel, 15 kilometers when the speed has been decreased by 5 kilometers per hour. So with these, it's always helpful to make a chart. And it's going to be a 2 by 3. And we have rate equals distance divided by time. Okay? So you have your initial situation and then your new situation. Okay? Before and after kind of thing. So here it says that we're looking for the time. So an expression for the time. So if that's the one I want, that's where we're gonna have to use this formula, distance over rate. It says make an expression for time. Doesn't mean we want a variable t. It means actually we want to make a rational expression. So distance over rate. So time it takes to travel 15 kilometers. So right away we know for both of them how far are we traveling. 15 kilometers. Okay. When the speed has been decreased by 5. So we need a variable for our speed because it says speed has been decreased by 5. So we'll let r be our initial speed. So before our speed was r, what's our new speed if it's been decreased by 5? Yeah? Okay, so what would be our new speed? R minus 5. Okay, so the last box is always made with the formula. And so time is distance over our rate. So our original time would be 15 over r, and our new time would be 15 over r minus 5. So our new time is 15 over r minus 5. Okay, so that's an expression for the time it takes to travel 15 kilometers when our rate has been decreased by 5. The next one, unit cost. Anyone know what unit cost is? The cost of one thing. Yeah, the cost of, so if you're, like how much it is per candy, for example. The unit cost of the total cost is 4,000 and the number of items has been increased by 5. So what's our unit cost going to be? So how do we usually find unit cost? If I have $10 for 12 items, how would you find it? 10 divided by 12. So our total cost over the number of items. So the total cost divided by the number of items. So what would be, in this case, our total cost is 4,000 divided by, how many items do we have? Well, what did they say about our items? Has increased by 5. So we need a variable for the number of original items. What do you want to use that for your variable? N, X, N. So N will be, let N be the number of items. And so the new number of items is n plus 5, increased by 5. So there's our expression. Okay, so these B questions, it might be helpful for you to make a chart. Rate equals distance over time. This time they want the speed of a car, so that's where we're going to use the formula. That traveled 50 kilometers, so we know before and after is both 50, that's our distance, in twice the time. So what's our variable going to be? Times 2 what? What times 2? X times 2, so we'll let X be the original time. So that would be our original time, so our new time is, it says twice the amount, so X times 2, or 2X. Okay, so how do we get one? Once you have 2 boxes, you just use the formula to get the third. So the rate here would have been distance divided by time, 50 over X, and our new rate is going to be 50 divided by 2X. So our rate is 50 over 2X, distance over time. Okay, this one there should be a lot of room for. Kara bought a case of concert t-shirts for $450. She kept 2 shirts for herself and sold the rest for $560, making a profit on $10 on each shirt. How much t-shirts were in the case? It's kind of a tough problem. The first thing we want to do is what's unknown? What are we looking for in this problem? Number of t-shirts. So let that be our variable. So let's start by defining our variable. So let do n. So let n be the number of t-shirts per, or in the case, right? The number of t-shirts in our case. So they give us some information. They talk about profit, and then they give us some information about how much she's selling it and how much she bought it for. So the profit for each shirt, how do we find profit for each shirt? How would you figure out the profit for each shirt? If you were actually buying and selling shirts, how would you figure out how much you made per shirt? The cost of one shirt minus what you bought it for, right? So how much is selling price minus the cost. So the profit for each shirt equals the selling price per shirt minus the buying price for each shirt. So we can figure out the selling price for each shirt and the buying using our n, right? We're going to write an expression for that. Do we know the profit for each shirt? Read the question again. It says make a profit of $10 for each shirt. Okay, so selling price, how much total money did she make selling? It would be, it tells us she sells it for how much money? All the shirts. Keep reading. That's for how much she bought it. She sold it for $560. No. Well, so total money she brought in for selling. Because we need to figure out, but here this was for n shirts. This is for n minus 2 shirts. Because she kept 2 shirts for herself. So the amount of selling price per shirt would be $560 divided by how many shirts she actually sold, which is n minus 2. Right? Because she kept 2 for herself, she only sold n minus 2 shirts. Okay, minus buying price for each shirt. She spent how much money? 450. For how many shirts did she buy? Let n be the number of shirts we should write here she bought. So just n. So n was in how much she bought. How much she sold was n minus 2 because she kept 2 for herself. Okay, so what would we have to multiply everybody by here? What's the lowest common denominator? What would it be? N and n minus 2. So we're going to multiply everybody by n times n minus 2. N times n minus 2. Okay, and some things are going to cancel out, right? The n minus 2's will cancel out here, and the n's will cancel out here. So now we got to do some algebra. On this side, should we bring this in now? 10n times n. 10n squared minus 10n times negative 2. Negative 20n. Okay, here we just have 560 times n, so we could just write that as 560n. Now this guy, we want to be careful because you have a minus sign here, so you might want to rewrite this one out. So we have minus, there's 450 times n minus 2. So what are we bringing in here? Negative 450. Want to bring in that minus sign as well. So 10n squared minus 20n equals 560n minus negative 450 times n, just negative 450n, and then negative 450 times negative 2, plus 900. Good. Okay, now there's an n squared here. So whenever we have an n squared, that's when we bring everything to one side. So we're going to bring everything over here. We have some like terms we can collect first if you'd like. 110. So 110n. Okay. So now we need to bring these two guys over. Let's do one at a time. So subtract 110 gives us 10n squared. What's negative 20 take away another 110? Negative 130 equals 900. And now what? Still want one side equal to 0. Who do we have to move now? The 900. So subtract 900 over. Okay, so once we have everything on one side, now we have to factor. First question, when we factor, is there a GCF? Yeah. So what can we divide all those by? 10. Let's factor the 10 out. N squared minus 13n minus 90. Dividing each by 10. Okay, two numbers that multiply to negative 90 and add to negative 13. So we need to use our calculators. I'm going to bring out the calculator. Oh. Come on. There you go. Okay, so we have two numbers that multiply to negative 90. So you can start dividing. So 2 and 45, right? Make a tree. 2 times 45. 3 times 20. No, 30. 90 divided by 3. That won't do it, right? So you need to add 13. Divide by 4. Won't go in. You can try 5. 5 and 18. Will that work? Okay, good. Which one has to be negative? We're going to add to a negative 13. Negative 18. Good. Okay, so we got factored form. just go n plus 5 and n minus 18 equals 0. So we get our solution n equals -5 or 18. Which one of these can we reject? -5, why? Can't have a negative shirts. So therefore, there were 18 shirts in her box that she bought. In the case. They were really nice shirts, okay? Dang. They're 18. They're expensive, aren't they? They want to make a lot of money. Okay. So grabbing your books, this little handout I gave you, right here. Thought I'd add. Oh my gosh, they cubed X. Okay. So your homework's going to be from here today, but I'd like to go through a question. So a lot of the problems, you'll notice that they gave you the box, right, to solve these. So there's two questions I want to go through. One of them is in here, and then your homework's in here today. So let's look at number 1, example number 1 on the next page. So read the problem carefully. Introduce a variable to represent an unknown quantity. Write an equation, solve the equation, and then write a sentence. So let's look at this problem here. Competing in endurance race, Shannon cycled for 120 kilometers and then swam 12 kilometers. Her average cycling speed was 8 times faster than her average swimming speed. Shannon took 9 hours to complete the race. If her average swimming speed is S, so they tell us that the average swimming speed is S. Write an expression for our average cycling speed. So what would our average cycling speed? Let's go back to this problem. Her average cycling speed was 8 times faster than her swimming, so 8S. Good. Okay, so we need to finish. What else do we know about this? Her distances. She traveled how far in cycling? That's a lot of kilometers of cycling. And wow, and 12 kilometers of swimming. That is an endurance race. Okay, so she spent 9 hours to complete this total race. So whenever we have 2 boxes filled in, we're going to use the formula to get these last boxes. Okay, so the formula for time, what's the time equal to? Well, distance, we're going to write it down again. Distance equals speed times time, or rate times time. Speed is distance over time, and then time is distance over speed. Good, so 120 over 8S. And what's this one going to be? 12 over S. So we have to make it a formula now relating our times together. So they have to tell us something about the time. What did they tell us about the time? How long did it take her to complete the race? 9 hours. What are we going to do with these two values then? If it's a total of 9 hours. Add them together. Her time cycling plus her time swimming is going to equal 9. So let's make that formula. 120 over 8S plus 12 over S equals 9 hours. Cool. Okay, so what are we going to multiply? We need to solve this. I think there's room to solve it on the next page. Yeah, so let's turn it over so there's room. I'm going to copy. Okay, so let's write this down again. It's like cheating, hey? Copy and paste. Okay, yep. You can reduce that. Okay, will 8 go into 120, or we just divide both by something? We can divide both by 4? Sure. Okay, so this we can reduce by dividing both by 4. 120 divided by 4, 30. What's 8 divided? Oh, we can probably, does 8 go into it? It does. 120 divided by 8 is 15. So we could just actually write 15 over s plus 12 over s equals 9. Okay, so what are we going to multiply everybody by? S. That's our lowest common denominator. So that we would make, so s, we're going to multiply that guy by s, and this guy by s, and that guy by s. Okay, what cancels here? S. What cancels here? S. We're just going to pause this. Okay, so we multiplied everybody by s. So what are we left with on this side? Let's close the door. Okay, guys, I need your attention again. 15 plus 12 equals 9s. Okay, what's 15 plus 12? Guys, Dean, stay with me. 27 equals 9s. Then we divide by 9, and s is 3. Okay, so what did that represent? Which speed? Which speed was that? Was that swimming or was that biking? Swimming. So therefore, it says solve her average swimming speed. Her average swimming speed, what were the units? Per 3 kilometers per hour. Okay, guys, let's get back to this math. 3 kilometers per hour. Okay, do you want to go through one more? Or do you get these? They make sense? Okay, I want to go through one more example, and it's in your workbook. So that's in your homework book, and that's this page. So it's the lesson 4.5. So if you go to page 109, okay, we need to look at this type of problem. It's the last type of problem you might see. So 109 in your actual blue homework booklet, the Principles of Mathematics 12. It's okay. Yeah, I'll give you a practice exam as well. Okay, so how we deal with these types of problems. So these are like the painting problems. So if I can paint a room in 2 hours and you can paint a room in 3 hours, how fast can we do it together type of problem. Okay, so the reason how we set these up is it's all related to one job over the time it takes. Okay, so for each person, they can complete one job per a certain amount of time. So this problem says, when working together, Marcia and John can do their housework in 9 minutes. That's together, 90 minutes. Working independently, it takes Marcia 10 minutes longer to John to do all of the housework. How long does it take John to do all the housework on his own? So first thing we got to do is set up a variable. So what are we looking for? How long it takes John to do the housework. So we need a variable for that. T? I don't know. Sure. Okay, so let T be the time. Okay, guys. It might show up on your diploma. That's why we're going over these questions. Let T be the time it takes John. John with no H. John to do the housework. To complete the housework alone. Hey guys, it's getting to the point we're going to have a seating plan again. It's like this all the time. Okay, so how we set it up is together, right? Together means we're adding them together. So what would be Marcia's time? If it says that Marcia takes 10 minutes longer than John. T plus 10. So Marcia can complete one job in T plus 10. Plus, John can complete one job in t time equals, they complete together, because we're adding them together, one job in 90 minutes. So that's how we set up those. So it's all set up with job over time. Okay, so what would we multiply everybody by? T times t plus 10 and 90. So each one of these, 90t times 10 plus t times, yeah. So each one of them, right? We need to represent each denominator. Plus 10 times 1 over t equals over 1 over 90. And then we can do our canceling to get rid of the denominator. Take a second to write that down. So those are the type of questions you can see on your exam, as well as possibly your diploma, right? So often speed problems, distance equals rate times time, or rate is distance over time, or these job type problems. 5. Okay, so t plus 10 cancels. What cancels here? T's and then 90. So we are left with, on this side here, 90t plus, Jesse, shh. What are we bringing inside here? The 90t or just the 90? Just the 90. The t's canceled out, right? So it'd be 90t plus, what's 90 times 100? 90 times 10, thank you. 900 equals, what are we expanding here? Why? Oh, that's why you have to have a little curve with your t, kind of like a J, backwards J. T times t is t squared plus 10t. We're bringing in the t. We have a squared, so everything has to be on one side. Yeah, so bring it over to the t squared. So we're going to minus 900. And what are these two add to? 180t. So I'm going to help just speed it up here. So we have t squared. If we subtract 180t, we get minus 170t minus 900. Yeah, it is 180, but there's already 10 there. So that's why I'm just going to help speed it up a bit. Okay, this needs to be factored. Yay. Oh my goodness. Okay, multiply to 900 adds to 170. Why? Because life is rough. Okay, so if that's too small. Oops. Okay, no. See if you can find the numbers. 6 and 150 won't work. What did I get? If it's not factorable, guess what we're going to have to use? Quadratic formula. Because I don't know if it's factorable. So a quadratic formula is negative b plus or minus the square root b squared minus 4ac over 2a. Well, here would be t equals. Did anyone find two numbers that it's factored to? No? Please? Okay, let me plug it in my calculator for you. So I'll plug it in. So negative b, a negative, maybe, yeah. So brackets around my numerator, 170, I'll do the plus first. Square root of 170 squared minus 4 times our a times our c all over 2. Okay, 175 and negative Okay, you can also use it graphingly. So grab your graphing calculators. I'm going to show you how to solve it graphically. Okay, so that's one way. So if we did that way, we get 175. And that would be in minutes. 175 minutes would be his time all alone. Okay, the other way is graphically. We can plug this into our calculator. So we put in x squared minus 170x minus 900. Yeah? Yeah? You have to do it twice. One for the plus, one for the minus. And because one of them was a negative, you can't have negative time. We reject the negative. That's why I got, yeah. So because we have set it to 0, our graph, we're looking for our zeros. Now you might want, we have to be able to see our zeros. So our windows here are all off. You could try zoom fit. Sometimes zoom fit, which is zoom 0, sometimes works. And what I'll do is try to show you, we need to see. No, it didn't work well. We need to see. So we'll have to change our windows ourselves. So -10. This is my y-intercept. So let's go to let's try 500. Scale of 50. And then you can go 0 to, it said 900, negative, oh, we have to go negative. This is our y-intercept. So maybe -1,000 to 1,000. We're just trying it out and see how that works. Oops. Yeah. I put -1,000. That should be 50. -1,000 to 900. So I'm using big numbers because that's my y-intercept, -900. You can also use the zoom feature on your calculator and just keep zooming out. Oh, what's wrong with my windows? Negative, not minus. Sorry, guys. -10. No, but that shouldn't be the issue. 50 y min. Oh, I thought I changed you. Gosh. Okay, so we want our 0 here, right? So to get our 0, what do we push? Second trace, and we want number 2. And so we have to go to the left side of the 0. So here's on the left side, push enter. Go to the right side, push enter, make a guess, and then it tells you it. 175. Okay? All right, so that's it for this lesson. So your homework is going to be from the handout I gave you. The reason why is just there's so much errors in the booklet. So can you open up to the homework? Okay, so the homework starts on page 480 of that handout. And the solutions are online already. Okay, so I'd like you to complete number 1, number 2, 1, 2, 3, 4. Okay, 1, 2, 3, 4. Yeah, and a minimum of a 1, 2, 3, 4. Actually, 1 second, let me help you. So open up to your, here we are. Guys, you getting this down? So question 1, question 2, then 3, all of 3, 4, okay, yeah, 4A, nope, almost all, 4A, and then, that's fine, you don't have to do that one, and then just number 7. Okay, so your homework is numbers 1, 2, 3, 4A, and 7. Okay, that's our homework. Okay, so work on your homework, and then we'll go from there. When you finish, show me.